Okay, good evening, students.
Good evening, sir.
Yeah. So electrochemistry completed now. Now we are going to start the next chapter, chemical kinetics. Can I start?
Yes, sir.
Yeah. So what is the chemical kinetics? It is the branch of physical chemistry, deals with the study of speed of the chemical reaction. And means velocity of the chemical reaction, nothing but rate of chemical reaction and factors affecting the rate of chemical reaction. So some applications we'll discuss in this chapter. So what is the take now? This is the chemical kinetics. So it is the branch of physical chemistry. Note down. Chemical kinetics is the branch of deals with the study of rate of chemical reaction. Rate of chemical reaction and factors affecting the rate of chemical reactions. Factors affecting the rate of chemical reactions. So, and right. Next, chemical types of chemical reactions. Next heading, take this one. Types of chemical reactions. Types of chemical reactions. So that means what are the types of chemical reaction means? Based on the velocity, or speed, velocity of the reaction, they are divided into three types. What is the first one is slow reactions. Second is fast reactions. Third is moderate reactions. Okay, now note it down. Then one by one we'll discuss. Can I clear?
So 1 minute. Yes, sir.
Right. So what is the first one is fast reaction, slow reaction. See, what is meant by slow reaction? The reaction occurs, the reaction, chemical reaction takes place in hours or days or months or in years, etc. Like that. A chemical reaction takes place more time, like hours, days, months, in years, etc. are known as slow reactions. Slow reactions. See, example, what are the slow reactions mean? Generally, reactions occurs between covalent molecules. Covalent molecules are the slow reactions. Slow reactions. So here, because bond has to break and bond has to make, that is the bond rearrangements due to slow reactions, due to bond rearrangements. Bond rearrangement. So that means new bond has to break between the reactants and new bond has to form a product side. That takes time. See, for example, H2 gas plus half O2 gas gives rise to H2O. H2O liquid, or NO, N2 gas plus O2 gas gives rise to 2NO. Yes. So this type of reactions takes a long time. See, for example, oxygen is there in atmosphere and nitrogen also is there in atmosphere, but both are combined, it gives N2NO, nitric oxide. But if it not occurs continuously, now if it takes any required conditions are happened under atmospheric conditions, when the suitable conditions are formed in certain time interval, then that case only nitric oxide is formed. That is acid rain in atmospheric air. So in such cases, it is very slow. Can't expect the time. How that is? If both reactants are available in free in atmosphere, but doesn't convert into NO, but it takes more time. That type of reactions are the slow reactions. Now down. Next, we'll take the instantaneous reactions or fast reactions. Completed, huh? Can I clear?
Just a minute. Done, sir.
Okay. Next, what is the fast reactions? Pen is stopped. 1 minute wait. This pen is stopped to write. So reconnection is required. Wait 1 minute. Once you remove and again, then only it will works. Yeah. Right. Next one is fast reactions. Second one is so what do you mean by fast reactions? The reaction takes place in fraction of seconds. The reaction takes place in fraction of seconds. Fraction of seconds means very fast. Fraction of seconds. Order is about 10 powers minus 16 seconds. That means 1 second, 1 over. But 1 by 16 times fractions of that second. So how fast you see expected? The reaction takes place at the range only, but it's a 10 power minus 14 to 10 power minus, it's not fixed, 10 power minus 14 to 10 power minus 16. It is a very fast reaction. Takes place in 10 fraction of seconds. The reaction takes place in fast fraction of seconds are known as fast reaction, or means very fast reaction. Fast reactions. Okay. Yeah, that means it's difficult to measure the order of the reaction. Now, what are the examples? Ionic reactions. Ionic reactions are fast reactions. Ionic reactions are fast reactions. So that means H plus aqueous ion, OH minus aqueous ion. So it becomes H2O liquid. Liquid. So that means two oppositely charged ions now. Oppositely charged means very fast, that is ionic reaction. Or neutralization reactions. Neutralization reactions are fast reactions. So what are the example? NaOH base plus HCl acid, it becomes NaCl plus H2O water. Fast. And all precipitate reactions are PPT. PPT means precipitate formation. PPT formation reactions. What are the examples? See, silver nitrate aqueous and NeCl sodium chloride, it becomes AgCl white PPT. White PPT is formed plus NaNO3. Or take the barium chloride solution aqueous. All are aqueous only. Barium chloride solution and treated with H2SO4. What will forms? Barium sulfate, white PPT. Barium sulfate, that is the white PPT. Barium sulfate, white PPT. White PPT. Okay. WHIT, white PPT. And what is the byproduct? 2HCl, right? Take this one, fast reaction, then we'll go for the slow, moderate reactions. Can I clear?
Yes, sir.
Yeah. Next. Same. What is the moderate reactions? Third one is moderate reactions. Moderate reactions. So what is meant by moderate reactions? The chemical reactions, their rate can be measurable, or known as, so which rate can be measurable. So write down the chemical reactions. The chemical reactions, their rate can be measurable. Can be measurable, or known as moderate chemical reactions. Moderate chemical reactions. Come on, what are the examples for moderate chemical reactions? Hydrolysis of ester. What the example is? Hydrolysis of ester. Hydrolysis of ester. So what is the CH3 COO C2H5 in acid medium H plus? So and means water only aqueous medium. What it will? CH3 COOH plus C2H5OH. And one more is the hydrolysis of sucrose. Hydrolysis of sucrose. What is hydrolysis sucrose formula? C12 H22O11. So hydrolysis glucose C6H12O6 plus C6H12O6 is the glucose. It is the fructose. Glucose and fructose. Okay. Right. Note it down.
Sir,
Yes.
is rusting of iron classified as a slow reaction?
It's not a slow reaction. It is a moderate reaction. You can measure the rate of reaction. So in the previous two cases, both slow reactions are very fast reaction, difficult to measure the rate of reaction.
Okay, sir.
Understood?
Yes, sir.
Yeah. Completed? Okay, can I clear?
So 1 minute.
You're writing?
Just a minute, sir. Okay, sir.
Yeah. Now come to the, what is the rate of reaction definition? Take the definition of rate of chemical reaction. Rate of chemical reaction. See, what is the definition of rate of chemical reaction means? It is the change in the concentration, the change of concentration of the species. So species means either reactants or products. That means reactants or products. In unit time, the change of concentration of the species in unit time. Unit time is the rate of reaction. Or we can define in another way. Change means what is change? Either increase or decrease. So the concentration of the reactants decreases or concentration of the products increases during the progress of the reaction. Or you can define the rate of chemical reaction means the decreasing the concentration, decreasing the concentration of the reactants or reactants 1 minute, reactants in unit time, decreasing the reactants in unit time, or overall increasing the products, increasing the concentration of products, increasing the concentration of product, increasing the concentration of products in unit time is known as rate of chemical reaction. Rate of chemical reaction. Understood all of you? The rate of chemical reaction defined as the change in concentration of the species, say the reactants or products in unit time. So generally the reactant concentration decreases, then at the same time concentration of the product is increased. How much quantity is reactant converted into product or consumed as a product, that much quantity of concentration increases for the products. Okay. Write down definition. Okay. The rate of reaction expressed as the rate of reaction expressed as dx by dt. What is the dx means? Change in concentration. Dx by dt or delta x by delta t. Here what is dx by dt means? Instantaneous reaction, rate of reaction. Delta x by delta t means average rate of reaction. Average rate of reaction. Where I am writing here. Where x by delta x by delta t is the average rate of reaction. Average rate of reaction. So what is the dx by dt is the, we are not able to write. Dx by dt is equal to instantaneous rate of reaction. Instantaneous rate of reaction. Rate of reaction. Note down. Yeah, completed, Amma? Can I clear?
Yes, sir.
Yeah. See, what is the rate means? With a change in concentration, right? And suppose A gives rise to product. With respect to reactants, I am showing that graphical representation. See this. See, this is the reactant concentration. What is the concentration of reactant? It is a, what is this? Is the time. Time means change in time. That is progress. RC means reaction coordination or progress of the reaction, or else it is a time. Okay. So this what is the suppose A gives rise to product. So what is the reactant concentration during the progress of the reaction? Decrease or increase? Come on, tell me now. A consumed into the products. That means the concentration of the reactants A decreases. The concentration of the reactant is A is decreases. How it is this? This is decreases like this. This is the decreases. A is decreases. So how it is? See this. Here A is the A naught. A naught means initial concentration of the molar concentration means square bracket is the molar concentration. That is a reactant only. Now I am writing here R1 concentration R1 here. Or this one, this is the time. At this, try to understand all of you. This is the T1. Here R2 concentration of reactant only, that is. Observe the curve here. What is this one? T2. So this difference now, this is time difference, right? The time difference means, so from here, this is the delta T. So from here, what is the concentration difference? That is simply you can say delta X or delta R I am writing because reactant. No? So what is the average rate of reaction? This is the average rate of reaction. Is the reactant not decreasing? Means that is minus delta X by or delta R by delta T. So understood all of you? Minus delta R by delta T is the average rate of reaction, or that is equal to R2 minus R1 by R1 by R2 because higher minus lower. R1 by R2 by, so T2 minus T1. This is the average rate of reaction. Understood? Now we make one tangent. For example, this is the, okay, try to this one, this region only. It is at time t. Okay, this is at time tm. T only, small t, at a small time. So what is this duration? Here this is the delta t, small delta t. So this part is dx. That means instantaneous rate of reaction. Instantaneous rate of reaction. Instantaneous rate of reaction. Rate of reaction. That is minus dx by dt. Minus dx by dt. Can you understood that instantaneous rate of reaction or average rate of reaction? Hello? Hello, students.
Yes, sir.
So, what is the average rate of reaction and instantaneous rate of reaction?
So instantaneous is like over a short period of a very small period of time,
Yeah.
but average is a longer period.
See, for example, general example I'm giving. For example, you this is the okay on Hebbal. I'm taking Hebbal point. From Hebbal to Dodapalapur, that is 30 kilometers, right? So now you start morning to 9 o'clock. Morning 9 o'clock, you started your car. So 30 kilometers reached by 12 o'clock. Suppose it's not not that much time, but it took 3 hours taken because of some full huge traffic. Now, what is the distance? Total is 30 kilometers, right? The distance traveled by 30 kilometers, and the time is 3 hours, 9 to 12. 12 minus 9 is 3. So 30 kilometers by 3 hours is nothing but average rate of reaction. But in particular time some distance. So from here to middle one, different stops are there. So one certain stop now, we are going to 80 kilometers per hour. So after 10 kilometers, only 10 kilometers, the 10 kilometers huge traffic is there. You are so riding only around that is 10 kilometers per hour. That is a slow. So if you consider a particular interval of time, that particular interval of time and interval of distance also, so in that particular zone, rate of the reaction is nothing but instantaneous rate of reaction. But the average total is taken different 3 hours. What is capital delta R by delta T? So small means particular interval. Wherever you have to consider that particular interval change in velocity. Understood? Hello?
Yes, sir.
Okay. Now I am drawing the curve with respect to product. This is the reactant concentration is decreases. The negative sign indicates decreasing the concentration or disappearance of the concentration. Note down here, note point. Note point is the negative sign indicates disappearance or decreasing the concentration of the reactant. Disappearance or decreasing the concentration of the reactant. Don't think negative sign is the low and positive is high. Irrespective of sign magnitude, it is not a magnitude. It is only decreasing and increasing. Can I clear? Okay, ma'am. Yeah, next. Take the rate of reaction with respect to product. Curve, see this. Rate of reaction. Rate of reaction with respect to products. So, yeah, changing this. Take this curve. What is the curve now? Now, what is the concentration of the product during the progress of the reaction? It is the concentration of product. Here, rate, time. So, what is the concentration of product? So, increasing, not decreasing, increasing, no? Right, like this, increasing. So, what is the here? 0. Here. And this is T1. It is a R, P. molar concentration of P1. Next. It is the T2. It is concentration of the product P. So now we take the average, means what is the this difference is nothing but delta T. It is the delta T. So here this difference is so delta X and delta P. Therefore, average rate of reaction reaction is equal to plus dP by dt. Here you know what is meant by plus. Appearance of the products or increasing the concentration of products. And now we can take this one tangent. This one. What is this time is T, small t. And this difference is a delta T, here delta X. Now what is the instantaneous rate of reaction? Instantaneous rate of reaction with respect to product, that is plus dx by dt, plus dx by dt or dp by dt. P means product. Not point right now here. Not positive sign indicates appearance or increasing the concentration of products. Okay, now done. Can I clear this? Completed all?
Yes.
Yeah, right. Next. So, what is the rate expression for general reaction? Rate expression for general reaction. So, what is general reaction? Suppose A plus B gives rise to C plus D. What is the rate expression? Say this. Minus D of A by dt is equal to minus D of B by dt is equal to plus D of C by dt is equal to plus D of D by dt. Understood or not? Or if you consider that another reaction, so what is another reaction means? Na plus Mb gives rise to Pc plus Qd. Here, what are the small letters? Are the number of moles of the reactants and products respectively. So, what is here? Small n, comma m, p, and Q are the number of moles of the reactants or reactants and products respectively. Then what is the rate expression? The rate expression can be written as, how to write now? Minus 1 by n. The number of moles can be expressed in the fractions. Minus 1 by n d of dA by dt, that is minus 1 by m into d of b by dt is equal to minus, not minus, plus 1 by p d of c by dt is equal to plus 1 by q d of d by dt. Here, why reactant side is negative, product side is positive means, so reactant side negative indicates disappearance, product side positive indicates appearance. Note it down. Yeah. Can I clear?
Yes, sir.
See, what is the meaning of last? The disappearance of A is equal to n by n, bring this side, n by m times of disappearance of B, or n by p times of appearance of C, or n by q times of appearance of D. Understood? Or disappearance of B is equal to m by n times of appearance of A, disappearance of A, and m by p times of appearance of C, m by q times of appearance of D, or appearance of C is equal to p by n times of disappearance of A, p by m times of disappearance of B, p by q times of appearance of D. That is the meaning. Okay, understood?
Yes, sir.
Now I'm giving some chemical reactions. You can write the expressions. Write the rate expressions for the following chemical reactions. Write the rate expressions to the following chemical reactions. Take now. One is, okay, N2 gas plus 3H2 gas gives rise to 2NH3 gas. Next, second, 2SO2 gas plus O2 gas gives rise to 2SO3 gas. 3. So N2 gas plus O2 gas gives rise to 2NO gas plus 4 H2 gas plus I2 gas is raised to 2Hi gas. Fourth, fifth, PCl5 gas is raised to PCl3 gas plus Cl2 gas. Okay, within 2 minutes you have to complete all.
Sir,
Okay, completed now? Hello?
Yes, so
sir,
Yes.
sir, in the fifth one, in the product side, it is Cl2, right? The second thing,
1 minute.
PCl3 plus Cl2, right?
Correct. Yeah, see this? I'm writing now, check it. First one is minus d of n2 by dt is equal to minus 1 by 3 d of h2 by dt is equal to plus 1 by 2 d of nh3 by dt. Similarly, second one also minus 1 by 2 d of SO2 by dt is equal to minus d of O2 by dt is equal to minus plus 1 by 2 d of SO3 by dt. Yeah, next, what is this one? N. So minus d of N2 by dt is equal to minus d of O2 by dt is equal to plus 1 by 2 d of NO by dt. Next, this one minus d of H2 by dt is equal to minus d of I2 by dt is equal to plus 1 by 2 plus 1 by 2 d of hi by dt. Last one minus d of PCl5 by dt is equal to plus d of PCl3 by dt is equal to plus d of Cl2 by dt. Understood? Hello.
Yes, sir.
Now I am giving one problem. You can calculate. What type of problems asked from you? Take this. In preparation of NH3 ammonia by Haber's process. The disappearance of hydrogen is, what are the units? I forget to explain units. Units of rate of reaction means dx by dt. Dx means change in concentration, means concentration units moles per liter, and time inverse. That one. Okay. The disappearance of H2 is 12 into 10 power minus 3 mole per liter inverse and time inverse or second inverse. Calculate the appearance of NH3 and disappearance of N2 nitrogen. Disappearance of nitrogen. Yeah, solve it now. Solution. Solve and tell the answers. I'm giving 1 minute, 2 minutes. Okay, what is the answer?
So the disappearance of N2 is 36 into 10 power minus 3. And the appearance of NH3 is 24 into 10 power minus. Sorry, 8 into 10 power minus 3.
What is the rate expression? Minus d of N2 by dt is equal to minus 1 by 3 d of H2 by dt is equal to plus 1 by 2 d of NH3 by dt. What is given? Disappearance of hydrogen is given, right? This part is given. So what I asked now? Okay, disappearance of nitrogen is equal to disappear. Therefore, what is the disappearance of nitrogen? N2 is equal to, so that is 1 by 3 into disappearance of hydrogen. Disappearance of hydrogen is given 12 into 10 power minus 3. It is 4 times. That is 4 into 10 power minus 3 mole per liter and second inverse. Correct? This one, all of you? Next, what I asked, appearance of ammonia. Therefore, from that equation only, appearance of NH3. So this is the d of NH3 by dt is the appearance of ammonia, no? So that appearance of ammonia is equal to this 2, bring this side here, 2 by 3 times of disappearance of hydrogen. Disappearance of hydrogen is 12 into 10 power minus 3. Now it is 4 times. So that is 8 into 10 power minus 3 mole per liter per second. So all of you get the same value, boys? Okay, now? Hello?
Yes, sir.
Next, we are going to discuss about the factors affecting the rate of reactions. Can I clear this? Hello?
Yes, sir.
Yes, so
Next, siding factors affecting the rate of reactions. So what are the factors affecting the rate of reactions? See, the rate of chemical reaction, the rate of, no down, chemical reaction influences the following factors. Yeah, this first one is nature of the reactants. Nature of the reactants. Second one is concentration of the reactants. Concentration of the reactants. Next, third is temperature of the reaction. Temperature of the reaction. Fourth one is catalyst effect. Catalyst effect. Fifth one is radiation effect. Radiation effect. So note it down. One by one we can explain. Okay, completed. Can I clear? Hello.
Yes, sir.
What are the 5 factors? That is nature of the reactants, concentration of the reactants, temperature of the reaction, catalyst effect, and radiation effect. Yeah. First heading, write down. That is the nature of the reactants. This pen is problem. What is the first one is nature of the reactants. 1 minute, all of it. Again, some problem is there in electric. This pen. 1 minute, I'll reconnect. Wait 1 minute, all of you students, please. Pen is sometimes. Yeah, it's fine. Right. What is the next one? First one. Nature of the reactants. Nature of the reactants. So the nature of the reactant already we discussed, right? You know, what is the reactions involved between ions or ionic substance? It is very fast. And the reaction occurs between covalent molecules. The reaction takes slow because there is a bond rearrangement takes place. Bond breaking and new bond is formed. So here higher the number of even that covalent molecules or covalent reactions also, the number of bond rearrangements are more, the rate of reaction is slow. The number of bond rearrangements are more, the rate of reaction is slow. See, for example, okay, write down times. Nature of the reactants. That means the rate of chemical reaction depends on the nature of reactants. So reactions occurs between ions or ionic compounds. Ionic compounds are fast reactions. Fast reactions. And the reactions occurs between covalent molecules. Covalent molecules. Reaction is slow. See, is slow. Due to bond rearrangements. So what is the meaning of bond rearrangements? Means bond breaking in reactant side and bond making in product side. Say for example, okay, I'll give even next point also you can write. By increasing the number of bond rearrangements, by increasing the number of bond rearrangements, the reaction becomes slow. The reaction becomes slow. So bond rearrangements is inversely proportional to rate of reaction. See, for example, so N2 plus O2 gives rise to 2NO, right? CH4, combustion of methane, it gives rise to CO2 plus 2H2O. Next, combustion of ethyl alcohol, C2H5OH plus 3O2 gives rise to 2CO2 plus 3H2O. So say equation 1 now, equation 2, equation 3. Now check the bond rearrangements, all of you. See this. In nitrogen between nitrogen, actually nitrogen between nitrogen triple bond are there, but don't think three bonds are has to break, because only sigma bond you have to consider, because pi bonds are equally, sigma bond only stronger, pi bonds depends on sigma bond. So independent, the strong one you have to break, that is the condition. So here one bond has to break. But oxygen, all three reactions are the combustion reactions only in presence of air or oxygen medium. So no need to consider the oxygen. So only major reactant is nitrogen. Okay. In nitrogen between oxygen, one bond is formed, sigma. So here 2 moles are there, means 2 bonds. So total number of bond rearrangements, how many BR? BR means bond rearrangements. Reactant side 1, product side new bond formed 2. So total is 3 of them. Now compare. Carbon, you know, like this. This is the carbon now. How many sigma bond has to break? 1, 2, 3, 4. So here 4, right? Okay, leave it oxygen. Carbon dioxide. So this, carbon dioxide C double bond O, but pi sigma bond only you have to consider. In CO2 molecule 2. Water, you know, HOH. How many sigma bonds? 2. But 2 moles are there. 4. Total now 10. How many BRs? 10. Next, ethyl alcohol. What is ethyl alcohol? See this. This H. OH. Come on, how many bonds here? 1, 2, 3, 4, 5, 6, 7, 8. 8 bonds in OH, C2H5OH. And here one carbon dioxide already, you know, 2. But 2 moles means 4. Hydrogen, water molecule 2. 2 into 3, 6. Total how many bond rearrangements in third equation? 18. Now what is the order of the rate of reactions? Increasing order I'm writing. Therefore, increasing order of the rate of reaction. Come on, tell me what is the first equation? Low now. First is greater than. Increasing order means first you take the less than. 1 minute. Increasing order means, what is the first lowest means 1 is less than 2 less than 3, right? Since BR is inversely proportional to rate of reaction. Rate of reaction. Oh, I'm sorry. BR is inversely. No. That is wrong. This is wrong. BR is inversely BR means lowest is third, 3 is less than, 2 is less than 1. Got my point? Hello?
Yes, sir.
Note it down.
Sir,
Yes.
if the rate of a reaction is less, it means it takes more time or less time?
Yeah, rate of reaction less means takes more time. More time means more number of bonds, rearrangements are more. That means takes more time, no?
Okay, sir.
More taking time means it is a slow reaction. Rate, speed only, velocity. And more taking time means it's a velocity.
So,
Ah.
but over here you've written 3 has least rate of reaction, and because it has maximum number of bond rearrangements, shouldn't it take the most time?
Ah.
So you've
More,
written 3 has
more,
least rate.
yeah, more time means rate of reaction less now.
Okay, so
Denominator value more means obviously it is the rate is less now.
if rate is less, more time.
Rate is equal dx by dt. Denominator time is more means it is the rate of reaction is less.
Okay, so got it.
Okay, completed. Can I clear?
Yes, sir.
Right. What is the next concentration of the reactants, right? Next, concentration of the reactants. concentration of the reactant. See this. What is meant by concentration of the reactants means when concentration of the reactants are increases, the rate of reaction increases. How it is increases means by number of collisions. When concentration of the reactants increases, number of collisions per unit time increases. Number of collisions per unit time is nothing but collision frequency. That means the collision frequency is directly proportional to rate of reaction. Take note. The rate of reaction increases with the increasing the concentration of the reactants. When increases number of collisions per unit time. Number of collisions per unit time increases. So that is collision frequency. Collision frequency increases. That is collision frequency, which is directly proportional to the rate of reaction. Proportional to the rate of reaction. Understood or not? So finally, what is the rate is directly proportional to that means minus dx by dt is directly proportional to c power n, or minus dx by dt is equal to proportional constant k into c power n. What is this one? Here C is the concentration. Here N is equal to number of reactants or overall order of the reaction. What is order? Later we'll discuss. Here minus dx by dt is the rate. Minus dx by dt means with respect to reactant. Okay, clear? Huh? Hello.
Yes, sir.
Yes. Next. What is the last? Next one. Third one. Temperature of the reaction, right? Temperature of the reaction. Temperature of the reaction. So listen now. What is the temperature of the reaction means? When the temperature of the reaction, temperature increases, what happens? You know, the kinetic energy of the reacting molecules increases. So kinetic moment increases and bombard means number of collisions also increases, collision frequency increases, rate of reaction increases obviously by attaining maximum kinetic energy. So for every raise of 10 degrees centigrade, the specific rate constant or rate of reaction is doubled. The rate of reaction is doubled. For every raise of 10 degrees centigrade, the rate of reaction is doubled. That is on one more temperature coefficient also is there. Now, Arrhenius proposed, okay, first matter you can write down not big derivation. Next page is required, continuation page. That page I will give the derivation part. Note down temperature of the reaction. The rate of reaction increases with the increasing of temperature. That means when temperature increases, collision frequency, direct temperature. Collision frequency increases by attaining maximum kinetic energy. So that is another important. For every rise of 10 degrees centigrade, the rate of chemical reaction or specific rate constant is doubled. Take this points. Next, Arrhenius equation is there, that small derivation part. Right here only. Arrhenius showed a relation. Arrhenius showed a relation between specific rate constant and activation energy of the reactants is known as Arrhenius equation. Note down. Okay, completed, huh?
1 minute, sir. Yes, sir.
Right. Next. So what is Arrhenius equation? We proposed an equation that is known as Arrhenius equation, I told, right? That Arrhenius equation is K is equal to A into e power minus EA by RT. This is Arrhenius equation. What is Arrhenius equation? K is equal to, say, equation 1, where K is the specific rate constant, where K is equal to specific rate constant, and A is equal to Arrhenius factor or frequency factor. Arrhenius factor or frequency factor. And EA is the activation energy. Activation energy. Now R gas constant. R gas. Next. T is the temperature. Temperature in Kelvin. Okay. Now for applying logarithm on both sides. Okay, natural logarithm. What is the natural logarithm? ln k is equal to ln k is equal to, log AB formula, log A plus log B. So ln A and minus EA by RT ln E base E. ln E base E is 1 only. So what is this equation now? ln K is equal to ln A minus EA by RT. Now, this is a natural logarithm. Now convert into common logarithm. Common logarithm means LOG will come. Here base E, it becomes base 10. That means 2.303 log K base 10 is equal to 2.303 log 10 log A base 10 and minus EA by RT. Now 2.303 can remove out. How it is removed? Dividing on both sides by 2.3, or else it become log of K is equal to base 10 need not be right. Log A minus EA by 2.303 R into 1 by T. What is this equation? Y is equal to mx, straight line equation is equal to mx minus c. It is a negative slope. See, for example, take this curve. What is a negative slope? Like this. It is a negative slope. What is the y means log k versus x means 1 by t, right? Negative slope. What is the slope now? Slope is equal to minus EA by 2.303 R. This formula also problems are there in objective questions. The slope formula also problems are there. Now say equation 2. Now down. Okay, clear? Huh? Hello.
Yes, sir.
Say this next. Now, what is equation 2? What is equation 2? Log of K is equal to log A minus EA by 2.303 RT. This is equation, right? Now, let us consider the two specific rate constants. Specific rate constants K1 and K2 at T1 and T2 respectively. T1 and T2 respectively. Now, you can write like this now. The first one, log of K1 is equal to log of K1 is equal to log of A is a constant only minus EA EA by 2.303 or 1 by T1. This is equation 3. Now what is equation 4? I am writing log of K2 is equal to log A minus EA by 2.303 or to 1 by T2, say equation 4. Okay. Now by subtracting these two, what will get? Come on, tell me now. Our equation 4 minus 3, you can take 4 minus 3 means log of K2 by K1 will come, right? Log of K2 by K1. So these two are cancelled. 4 means minus, by taking minus is equal to minus EA by 2.303 or is a common. So what will come? 1 by T2 minus 1 by T1. Correct? Hello?
Yes, sir.
1 by this formula is required to calculate many problems. Note down this formula. Okay, completed. Next, what is the temperature coefficient? Is there? Hello?
Yes, sir.
Next, temperature coefficient. See this. Here, what do you mean by temperature coefficient? It is the ratio between specific rate constants, specific rate constants K1 and K2 at T1 and T2, which are differ by 10 degrees centigrade, which are differ by 10 degrees centigrade. Okay, so differ by 10 degrees centigrade. So that means temperature, and again that's value. 1 minute. That's value is in between 2 and 3. Okay, therefore the temperature coefficient is equal to the K1 at T1 plus 10 degrees centigrade divided by K2 at T2. This is the temperature coefficient formula. Temperature coefficient formula. The students, hello.
Yes, sir.
Starting in electrochemistry, I sent many questions around 200 above questions, sir. Solved or not?
So we have a lot of school work, so we're still solving it.
A lot of school work, that's why I didn't solve it. When you will solve this exercise, what I am giving? This weekend?
Yes, sir.
Okay. So next week I'll try to come chemical kinetics also. It is a big chapter and important, very, very important chapter. So are you following or not? You are following all the students?
Yes, sir.
Yes, sir.
So totally how many are there in your section, your class? Anybody? Hello?
No, I don't know.
You don't know?
Like in the beginning when we were coming to class, I think we were about 12 of us. And then I don't know how many people joined online.
Okay. You are not able to observe the group. How many are there? No option for you.
So today we have only 10 people.
Now 10 only. Starting some 13 or to 13 are there. So why these people are not coming to class properly? Not writing. Preeta, you only talking now.
Yes, sir.
Jaipal. Okay. Okay. Adira, Jite, Jayjit.
Yes, sir.
You're writing notes, Amma? Any doubts?
Not yet. Sir.
All of you go through that electrochemistry and solve one by one question. You will get doubt definitely. So in that doubt, what we will discuss. So I put in that group. Nobody can do it. Nobody asking. So it is not correct now. So you have to. You also do the work. Then Pawan, CS. Hello, Pawan.
Yes, sir.
Electrochemistry questions you didn't solve.
Doing, sir.
No one can ask the questions, doubts. Tarunya,
Yes, sir.
you solved electrochemistry?
So I'm still solving it.
You are following this chemical kinetics?
Yes, sir.
Can I add some questions from chemical kinetics in that Google Classroom assignment? Based on rate of reactions, small questions only.
Yes, sir.
Okay, Mari. Next class I will. Any doubt today's class? Students, any doubt in today's class?
No, sir.
Okay, thank you very much.
Thank you.
Thank you.